This video will introduce you to basic data types in Python. In a previous video, we looked at the basic data types. In this clip, we're going to look at potential traps that you could encounter using those. Let's start. Simple example. We have our list C. That was our list 1, 2, 3, 4. So if you don't remember, we can go up, or we can simply enter it here and say, oh, print C. As a reminder, C was a list 1, 2, 3, 4. So now I execute this code. I copy C to a variable new. It's a new variable new. That's a copy of C. And if I do this, I print C and I print new. Nothing that we didn't expect. So how about now let's change the second entry in the list new to the number 99. The second entry, so this entry, again, remember indexing, index 0, index 1. So the second entry is index 1. List new, the second entry, so we use that indexing, we assign the number 99. And we see if I print the list new, it's nicely changed. Here comes the trap. We modified new. So typically we don't even think about questioning what happened to C. But look at this, if I print C, C changed. I did not touch C anywhere, it seems, but the second value of C also changed. And that is very confusing for the beginner. And that brings us to a bit more advanced computing. Because the concept, what's going on here is that the variable C is actually not the data. Data is stored somewhere in the computer's RAM. The variable C is a pointer that points to the start of our data in memory. So when I executed here, new equals C, I did not make a copy of my data. I made a copy of the pointer. So new and C are both pointing to the same block of memory on my computer. When new modified the data, it didn't modify the pointer. It's pointing at the data. So now I use this pointer pointing into memory. This is modifying the memory. Since C and new point to the same part of memory, when I say print C and print new, they both point to the same chunk of memory. They both print the same stuff. So this, again, is copying the pointer to the data, is not copying the data. And that's something we can use because it makes a much faster way of sharing data. We don't need to copy, we don't need to duplicate. But sometimes we want new to be a copy of the data and not just point at the same data. There are a bunch of options to do this. The cleanest way is possibly this one. So let's look at this. I have to reset my list C. And instead of saying new equals C, I say C, use your copy function to create a copy of the data and give this to new. So if I do this with the copy function, we see that if I print C, I modify new, I print C, and C was not changed. So again, for those of you who may have forgotten this, if I do it this way, I copied the pointer, if I use the copy function, I copied the data, and UNC has independent sets of information, independent sets of data.